Chapter 7. Particulate nature of matter. Composition of matter. Matter is anything that has mass and occupies space. It is made up of extremely small particles called constituent particles, the basic units of matter. Between these particles, there exist interparticle spaces, smallest in solids and largest in gases. Different states of matter. The particles that make up matter are held together by forces called interparticle attractions. The strength of these forces depends on the type of substance and the interparticle distance between particles. Even a small increase in the distance greatly weakens the interparticle forces. Solid state. Solids have a definite shape and volume because their constituent particles are packed closely together. These particles are held firmly in fixed positions by strong interparticle forces of attraction. Due to these strong forces, particles in solids cannot move freely but only vibrate or oscillate about their positions. The solids maintain their shape unless acted upon by an external force. When heat is applied, the particles vibrate vigorously and leave their positions. At a certain temperature called melting point, they gain enough energy to overcome these attractive forces. This causes the solid to melt and change into a liquid. Different solids have different melting points depending on the strength of their interparticle forces of attraction. The melting point of ice is 0 degrees Celsius. The melting point of urea is 133 degrees Celsius. The melting point of aluminium is 660 degrees Celsius. Thus, substances with stronger interparticle forces of attraction have higher melting points, while those with weaker forces melt at lower temperatures. Liquid state. Liquids do not have a fixed shape but possess a fixed volume. They take the shape of the container in which they are kept, but their volume remains the same. The particles of a liquid are held together by interparticle forces of attraction that are weaker than those in solids but stronger than those in gases. This allows liquid particles to move freely, only within a limited space. Boiling and evaporation. When a liquid is heated, the movement of its particles become more vigorous. With heating, the liquid reaches a stage when it starts converting into vapor. The temperature at which a liquid turns into vapor at atmospheric pressure is called its boiling point. At the boiling point, the movement of particles becomes so vigorous that they move apart from each other, resulting in a decrease in the interparticle forces of attraction. Eventually, the constituent particles can escape from the liquid state. The liquid is converted into vapor or the gaseous state. At the boiling point, bubble formation occurs within the liquid. This is because vapor is formed not only at the surface but also inside the liquid. Evaporation is the slow process of vapor formation that occurs at all temperatures and even at temperatures below the boiling point. Vapors are formed only at the surface of the liquid. Gaseous state. In gases, the constituent particles are very far apart from each other compared to solids and liquids, and their interparticle attractions are very weak. Because of this, gas particles are free to move randomly in all directions, colliding with each other and the walls of container. This motion causes gases to spread throughout the available space uniformly. Thus, gases do not have a definite shape or volume. For example, when we take solid iodine into a gas jar, it changes directly into iodine vapor at room temperature and vapor spreads freely inside the gas jars. Liquids and gases share a common property as they can flow and do not have a fixed shape, classifying them both as fluids. Interparticle spacing in different states of matter. The space present between the constituent particles of matter is called interparticle spacing. The extent of this spacing determines the physical properties of solids, liquids, and gases. In solids, particles are very closely packed with negligible interparticle spacing. They are held together by strong forces of attraction and cannot move freely, but only vibrate about their fixed positions. Thus, solids have a fixed shape and definite volume. They are incompressible. In liquids, particles are less tightly packed as compared to solids. They move more freely because of larger interparticle spacing and weaker forces of attraction. Thus, liquids have a definite volume but no fixed shape. They are nearly incompressible but allow other soluble substances to dissolve. In gases, particles are very far apart and move randomly. The interparticle spacing is extremely large and forces of attraction are negligible. Because of this, gases have neither a fixed shape nor a fixed volume. They are highly compressible. Movement of particles in different states of matter. The movement of particles in solids, liquids, and gases depends on their interparticle spacing, the strength of attractive forces, and the thermal, heat, energy they possess. All particles of matter are in continuous motion, but the extent of motion varies in each state. In solids, the particles are very closely packed. The forces of attraction between particles are very strong, and the thermal energy is very low. As a result, the particles cannot move from their positions but only vibrate about their fixed points. This restricted motion explains why solids maintain their definite shape. In liquids, the interparticle spacing is larger compared to solids, and intermolecular forces are weaker. The particles have more thermal energy, which allows them to move and slide past one another within the liquid. This motion explains how substances like sugar or potassium permanganate can dissolve in water. The moving water particles pull the solute particles out and scatter them. The rate of particle movement increases with heat. Hot water particles move faster, so solutes spread more quickly in hot water rather than in cold water. In gases, the particles have the highest thermal energy. They are far apart and the forces of attraction between them are negligible. The particles move freely in all directions with high speed. When a substance such as the fragrance from an incense stick is released, the particles of the fragrance collide with moving air particles and spread rapidly throughout the room. This demonstrates that air particles are always in constant motion.